Now that we have all the multiplication properties of powers, let's start taking a look at the division properties. Let's simplify 2 to the 7th divided by 2 to the 4th. 2 to the 7th, if you remember, is 2 multiplied by itself 7 times. 6, 7 twos. And then in the denominator we have 2 to the 4th, so that would be 2 multiplied by itself 4 times. And since we have common factors in the numerator and the denominator, like this 2 and this 2, they'll cancel each other out. And so will these 2's and these 2's and these 2's. If we look at what's left, it's just this much of it, which is 2 to the 3rd power. Of course, that's going to end up being 8. But what's interesting here is that when we're taking two powers that have the same base and we're dividing them, how did we get from having powers of 7 and 4 and ending up with 2 to the 3rd? Well, it came through all that canceling, and so we did 7 minus 4, and to get that 3. So if we had x to the 20th over x to the 15th, right? Well, x to the 20th is going to mean x times x times x a whole bunch of times, right? In fact, not just a whole bunch, but specifically 20 times. And in the denominator, we're going to have a bunch of x's as well. Just not quite as many, because there will only be 15 of them. The process is still the same. That since we have factors that are the same in the numerator and the denominator, they're going to cancel. Right? Those ones, those ones, those ones. In fact, everything will cancel. And since there's more x's in the numerator than there are in the denominator, everything out of the denominator is going to cancel, and we'll be left with this many x's, however many that is. And we can figure that out because, well, 15 of the x's that were in the denominator canceled with 15 of the x's that were in the numerator. If we took 15 of those x's out of the numerator, we're left with 5 more. So 20 minus that 15 leaves us with x to the 5th power. And that's what the quotient of powers property is. That if we're dividing two powers where the bases are the same, what we do with those exponents is to subtract them. So if we have an expression like x to the 3rd, y to the 4th, divided by x squared y, what we can do is just kind of split them up right here. So looking at it as x to the 3rd over x squared times y to the 4th over y, and then use that division property that we have in the first fraction. Our bases are both x, and we have a power of 3 in the numerator, power of 2 in the denominator. We see that division, so we're going to subtract the two powers. 3 minus 2 is 1. And for the y's, we have y to the 4th over y, and of course that y in the denominator has a power of 1, so we subtract those two. 4 minus 1 is 3. And we should simplify this, write it as x times y to the 3rd. Let's try one more. If we have k to the 7th, m to the 10th, p, divided by k to the 5th, m to the 3rd, p, right? Split them up into those, each of their own fractions, k to the 7th over k to the 5th. Okay? And m to the 10th over m to the 3rd. And p over p. Since we're dividing two powers with the same base, we're going to keep the base the same and subtract their powers. 7 minus 5 is 2. For the m's, 10 minus 3 is 7. And for the p's, well, we got p to the 1st and p to the 1st. 1 minus 1 is 0, but, I mean, the numerator and the denominator are the same, so they're going to cancel, and that's the same as multiplying by 1. So our answer is k squared m to the 7th. And what if our fraction is the base of a power where the numerator and the denominator are not the same, but we're taking this fraction to the 3rd power? Remember that when we're taking something to the 3rd power, we take that base and multiply it by itself 3 times. So we'll have a over b times a over b times a over b. And a times a times a is a to the 3rd. B times b times b is b to the 3rd. So we see that what happened here was that when we had a fraction all to the third power, we ended up with an answer that had the numerator to the third power and the denominator to the third power. So our power of a quotient property is that if we have a fraction as the base and we're taking that fraction to any power, the numerator gets taken to that power and so does the denominator. So when we have 3p to the third over 7 being squared, that means we're going to take the numerator, 3p to the third, and square that, and we'll take the denominator, 7, and square that one. Now, in the numerator, we have a product, 3 times p to the third, that's being squared. So we have that other property, the power of a product property, that says each factor in that base would get squared as well. So we'd have 3 squared times p cubed squared all over 7 squared. Now when we simplify each part, 3 squared, that's 3 times 3 is 9. P to the third to the second, so we have a power to a power. That would mean that we're going to multiply those two together, so p to the sixth, and 7 squared is 49. So this would be our final answer. Try one more. If we had 2y squared over 3z to the third, all to the third power. Kind of the shortcut of this is that every factor inside that set of parentheses gets taken to the third power. So we'll have 2 that gets taken to the third power. Y squared would be taken to the third power. In the denominator, 3 gets taken to the third power. And z cubed gets taken to the third power. Now let's simplify each one of those factors. Remember that when we take something to the third power, like 2, 2 to the third power is 2 times 2 times 2, which is 8. In the denominator, 3 to the third is 3 times 3 times 3, which is 27. For y squared to the third, we have a power to a power right here. And so we multiply those powers together. 2 times 3 is 6. And the same thing in the denominator. We got z to the third, so we need to multiply those two powers together as well, and we'll get z to the ninth. And there's our final answer.